Okay, so problems 3 and 5 are the ones that I took for project 2, and I'm in group 6. So problem 3 says find the limit of the sequence, and then it gives it right here. And so it gives us a hint saying use the properties of exponents, uh, which the hint is the square root of 2 equals 2 to the 1/2. So if we look right here, this is my scanned document of the two problems. So problem 3, I wrote out the problem and I stated the hint. So as you can see here, the first term is the square root of 2. So I wrote a1 equals the square root of 2, and then I did the same for a2 and a3. So term 1, term 2, and term 3. And then I wanted to, while I'm finding the limit of this, I kind of wanted to make it a little bit easier on myself. So what I did was I used the hint, so it's 2 to the 1/2 for the square root of 2. And so for the second term, it's 2 to the 3/4, and the third term, it's 2 to the 7/8. Sorry about that. I just kind of simplified this. And so if you want proof on how I got these, so I'm proving that this right here is equal to 2 to the 3/4. So the square root of AB is similar to the square root of A times the square root of B. So this right here, the B term, I use the smaller square root. So the square root of 2, that's term B. And then the bigger square root, the square root of 2, all inside the bigger square, or the square root. Sorry about that. So for the A term, I said 2 to the 1/2 times 1/2 was what this was, because the square root of 2 is 2 to the 1/2, and then it is all inside a bigger square root, and that's to the 1/2 as well. So that's how I got 2 to the 1/2 to the 1/2. And then the square root of 2 is just 2 to the 1/2. So I multiplied these and got 2 to the 3/4, and that's how I got the 2 to 7/8 for the third term. And then, yeah, that's how I solved for kind of simplifying this. So while I'm looking at these terms right here, I can actually see that the denominator of the exponents, so not the 2, so just the denominator of the exponents, they're raised, their power is a 2. So 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. And so the first term is the exponent, which is 1/2. So I said kind of one of the ways you can write this is, so the 2 is constant. That's why I'm kind of avoiding it right now. That can be for later. So 1/2 is similar to 1 over 2 to the n, and that's kind of how I solved that. So there are, like I said, there's many ways to solve this, but I feel like this is easier. This how I wrote it, 1 over 2 to the n. So that's how I got the first term. And then for looking at the exponent for the second term, it's 3/4. So you can't multiply by 2 and add 2 to the numerator. You can't do all that. That's just, it gets way too messy. So I wanted to find a scenario where there can be a limit for the exponent that can be consistent throughout the sequence. So after looking through many scenarios, I noticed that 1 minus 1 over 2 to the n is actually one way to solve this. So let's test it out here. So 1 minus 2 to the 1 power, that's just 1 minus 1 over 2, which is just 1/2. So right here, that's correct. We have the square root, or the exponent, 1/2. And then let's test it for the second term. So 2 to the second power, so 1 over 2 to the second power is 1 over 4. So 1 minus 1 over 4. Now, it may look a little difficult to solve this, but you just make these common denominators. So 1 over 1 is similar to 4 over 4. So 4 over 4 minus 1 over 4 is 3/4. And bam, we have that in the second term. And so I did that for the third term as well. And so I noticed that this was consistent and it worked because we can see the pattern. It's continuing like at this pace as each term goes up by 1. So I said the limit was limit and then n to infinity 2 to the power of 1 minus 1/2, 1 minus 1 over 2n. Sorry if I said that a little weird. So I actually wanted to evaluate this limit. So, or actually before I evaluate it, you notice that I can bring the 2 out. Sorry. You can notice that I can bring the 2 out. So I took the 2 out, and so it's 2 and then the limit of the exponent of 1 minus 1 over 2n. And so I got, so you can actually simplify this. So since this exponent has 2 parts to it, this is the same as 2 to the first times 2 to the negative 1/2 n, or 1 over 2n. And so that's what I did here. And so I evaluated it from there. I kind of simplified it, made it easier on myself. So I have the limit of n, or limit, and then n to infinity, 2 to the power of 1 times 2 to the power of negative 1 over infinity. And I use that infinity because that's our n right here. I want to substitute that. And so 2 to the power of 1 is just 2, and then 2 to the negative 1 over infinity is just 1. And so I got 2 for the final value, and it converges to 2. So it asked for the limit. It didn't ask if it converged or diverged. I just kind of wanted to state it. I thought it would make stuff a little more clear, and I just wanted to elaborate on it more. So yeah, this is the limit, and then it converges to 2. Now, if we look on problem 5 asks, does the series 1 over n and then natural log of n converge or diverge? So actually, right here, video 15, it explains the integral test. And so sorry about that. I actually used that. That's the test I used for this, and I showed all my algebra here. So we noticed that n equals 2, and that's our lower bound. So we're going to actually turn this into an integral. And so we want to set up the integral first in order to solve this problem, as it's stated in the test. So we have the integral, and then the lower bound is 2, the upper bound is infinity. And then I have 1 over n natural log of n dn. I could have wrote dx, however, it's in terms of n. If this was in terms of x, I would have wrote it that way, but I just wrote dn to kind of make it easier for me. So I wanted to use the chain rule, and so I have u equals the natural log of n, and du equals 1 over n. So, or du is the derivative of this, which is just 1 over n. And so I took that, and we have the integral of 1 over u, du, and then which is just the natural log of u, and we said u was natural log of n, so that, and as it's stated right here, so the antiderivative of this is natural log and then of natural log of n. I don't know if that sounds a little confusing, but that's how I did it. So I evaluated it, so natural log of infinity minus natural log of 2, so we're evaluating it from here. It's actually just infinity. So I stated that it diverges. And let me pull this out really quick. So, and my explanation was to kind of make it a little more clear. I said it's shown above in the integral test that it demonstrates that since the integral diverges to infinity, then the series will diverge as well. So if the integral diverges in any way, then the series will also diverge. And so that's how I kind of solved this problem, went around it. So yeah, I used the integral test, and it diverges because it's infinity, because the integral diverged, so that means the series will diverge as well. So yeah, that's how I solved problems 3 and 5. I hope I made everything clear. I tried to go through everything pretty thoroughly. So yeah, that is all.